Hi everyone, welcome to Easy Math. Today in this video, we'll see chapter 1, class 8, rational numbers. In that chapter, we'll see about the properties of rational numbers. We have already seen the introduction. Now in this, we'll see the properties of rational numbers. There are 6 properties we have, which we have studied already for whole numbers in 6th standard and for integers in 7th standard. Now we are going to do the same properties for rational numbers in 8th standard. The properties are closure, commutative, associative, identity element, inverse, and the last one is distributive property. Now each of these properties we are going to see for all the 4 operations of mathematics, which are addition, subtraction, multiplication and division. First we'll see closure property for all the 4 operations. So closure, first we are starting with closure. Closure for addition we'll see. What does this property mean? It means when you add 2 rational numbers, the sum is also a rational number. That is, when you add 2 rational numbers, the answer you get is also a rational number. For example, in general, a rational number is taken as a by b. We know general form of a rational number is p by q. Here, for example, we have taken a by b. A is the numerator, b is the denominator. Here, c by d, c numerator, d denominator. It is in p by q form. So, a by b plus c by d. When you add 2 rational numbers, the sum is also a rational number. We'll see an example. You understand better with an example. First rational number is 3 by 8 and the second rational number is 2 by 8. So add them both, 3 by 8 plus 2 by 8. Because the denominators we have the common denominator, so put 1 8 and add the numerators. 3 plus 2 is 5. See, I'm explaining all these properties along with the examples, so that when you do the exercise sums, how we are doing the examples here, only they are the sums in the exercise given. Okay, so that if you understand this introduction better, then exercise sums will be easier to do. Okay, and one more thing, just to explain the properties only, I'm taking the examples. So I've taken in all the sums, I've taken the common denominator. While doing the exercise sums, you will have different denominators. There you have to find the LCM and then perform the operations addition or subtraction. Okay, children. So when the sum of 2 rational numbers is again a rational number. 5 by 8 is also a rational number. That is for closure property for addition is true. Now we'll see the closure property for subtraction. What does it say? When you subtract 2 rational numbers, a by b minus c by d is also a rational number. So we'll take an example, 7 by 11 minus 3 by 11. For both the denominators, one denominator 11 and 7 minus 3 is 4. So 7 by 11 is a rational number, 3 by 11 is a rational number, 4 by 11 is also a rational number. So the closure property is true for subtraction also. Now we'll see for multiplication. A by b into c by d is a rational number. When you multiply 2 rational numbers, you get a rational number. That is, for example, 3 by 5 into 2 by 7. In multiplication, the denominators can be same or different. Anything you are like and unlike, both can be multiplied. Just multiply both the numerators and multiply both the denominators. 3 2s are 6 and 5 7s are 35. So 6, the product 6 by 35 is also a rational number. Now we'll see the closure property for the last one, operation division. That is, if a by b and c by d are 2 rational numbers, then the division of them is not always a rational number. The previous 3, they are always rational numbers. But here they are not always a rational number. Why? We'll see an example 1 here. 7 by 15 divided by 2 by 3. This division we studied already. First, a rational number, write as it is, then change how to perform division we have done in the fractions. Same procedure we follow. Change division into multiplication and write the reciprocal of the second number. Second 2 by 3 becomes, the reciprocal is just changing the numerator and denominator. So 2 by 3 becomes 3 by 2. Now when you multiply, it is 7 3s are 21 and 15 2s are 30. And now otherwise you can cancel this. These two can be cancelled further. That is 3 7s are 21 and 3 10s are 37 by 10. It can be cancelled here, or even before multiplying we can cancel here and also multiply. That is the simplification part. But the final answer 7 by 10 is also is a rational number here. But 0, we know 0 is also a rational number. So 3 by 5 is a rational number. When you divide by 0, we have studied already in the definition of rational numbers itself, division by 0 is not possible because 0 is also a rational number. So when you divide rational number by 0, here this division is not possible. We are not able to divide. That is why we say the division is not always closure. When the denominator is 0, the division is not closure. Closure property is not true for division. Otherwise, it is okay. We are getting a rational number only. So when the denominator is 0, when you are dividing by by 0. Closure property is not true for division. That's why we say it is not always a rational number. So this is about closure property. Now we'll see about second property, which is commutative property. We'll see commutative for all the 4 operations. First we'll take addition. So it says a by b plus c by d is equal to c by d plus a by b. What have we done here? If you observe keenly, you will understand that the order of the addition is changed. The first fraction has become second rational number. Second rational number has become the first rational number. Even if you change the order of addition, the sum, the answer will not change. We'll see an example. 3 by 7 plus 2 by 7. You complete the left, this, if you change the order, it becomes 2 by 7 plus 3 by 7. So we'll finish the left hand side first. The 3 plus 2 is 5 by the common denominator 7. Here 2 plus 3. Whether you add 3 with 2 or you add 2 with 3, we get the same answer. So even if we change the order of addition, the answer, the sum will not change. So commutative property is true for addition. Now we'll see for subtraction. It is 2 rational numbers here, a by b minus c by d, and right hand side is change the order, c by d minus a by b. It is actually not equal to. We'll see whether it is this is true or not. Now take 2 rational numbers. The same rational numbers I've taken 7 by 11 minus 3 by 11. So if we change the order here, it becomes 3 by 11 minus 7 by 11. So it becomes 7 minus 3 is 4 by 11, and 3 minus 7 is, when you subtract and put the sign of the greater number. So sign of 7 is minus. We get minus 4 by 11. 7 by 3 is plus 4 by 11. 3 minus 7 is minus 4 by 11. Plus 4 by 11 and minus 4 by 11 are not equal. Therefore, this commutative property is not true for subtraction. Okay, now we'll see for multiplication. A by b, multiplying 2 rational numbers, a by b into c by d. Now we change the order here, it becomes c by d into a by b. Now we'll check whether they are equal or not with an example. 3 by 5 into 4 by 11. You change the order here, you get 4 by 11 into 3 by 5. So when you multiply, 3 4s are 12, 5 11s are 55. Here also 4 3s are 12, 11 5s are 50. Whether you multiply 3 by 4 or 4 by 3. 5 into 11 or 11 into 5. The answer is not changed. It is the same rational number we are getting. So commutative property is true for multiplication. Now we'll see for we'll see the property for division now. This is the commutative property for division. What it is? A by b divided by c by d. The other side is c by d divided by a by b. It's actually not equal to. We'll check now. For example, 3 by 5 divided by 4 by 7. And when you change the order, it becomes 4 by 7 divided by 3 by 5. Now we'll perform the left hand side first. That is, how do we divide? We write the first rational number as it is, change division into multiplication, and 4 by 7, write the reciprocal of the second rational number. 4 by 7 becomes 7 by 4. Right, as I will complete this, then we'll move on the right hand side. Now it is the division is changed into multiplication. Now it is we have to perform multiplication of rational numbers. That is 3 7s are 21 by 5 4s are 20. That's all the answer. It cannot be simplified further. Now we come to the right hand side. Write the first rational number 4 by 7 as it is, change division into multiplication, and 3 by 5 becomes 5 by 3. So now here, multiply them. 4 5s are 20 and 7 3s are 21. Now check both the sides now. Left hand side is 21 by 20. Right hand side is 20 by 21. Are they equal? No, they are the reciprocal of each other. These two rational numbers are not equal. So the commutative property is not true for division. So it is true for only addition and multiplication and not true for subtraction and division. Okay children, we'll complete this video with this, and the remaining 3 more properties we'll see in the next video. Okay children, thank you for watching. Thank you.